Hi, this is Gracie. Today you're going to learn graphing rational functions.
Alright, so let's get started. We got a little special guest intro the video for you guys, just for fun today. So we are graphing these rational functions, but we've kept it really simple for you guys because we already know this is tough stuff. So in the beginning, there was a definition, and the definition defined rational function. Basically what it's saying is it's a polynomial divided by a polynomial, okay? So we're not graphing right out of the gate here. We're going to learn some things really quickly. So a rational function is something that when you graph it, instead of looking like a line, there's a line, or another graph you're familiar with, like a parabola, or another graph that you guys are familiar with, absolute value. Instead of looking like this, you may or may not have seen a rational function. And a rational function has something called an asymptote. So that's an asymptote. It's a vertical asymptote because it's up and down. And then it'll have some sort of horizontal asymptote as well. Not all of them have horizontal asymptotes. We'll learn about that in a little bit. And the graph likes to coast along its asymptote. So it likes to do this little turn right there, and this one would probably do something like that. So the graph, there's an example of one. They don't all look exactly like that, but that's what a rational function is going to look like. So before we can even start into getting out how to do that, we need to learn how to find this type of asymptote, which is vertical, and this type of asymptote, which is horizontal. So I'm going to tell you guys something. Vertical asymptotes always start with x equals. They're x equals lines. So I say exertical instead of vertical because in our world of math, if we see something that's vertical, we think y. Why? Because y's are vertical. But if you actually look at this, the x's are all the same on this line. Like this would be 2, -7, and this point right here would be 2, 0, and this point right here would be 2, 4, hypothetically. But if you notice, all the x's are saying the same. So all vertical lines are exertical. They start with x equal, and all horizontal lines are y equals because the y's are all the same height. So this is horizontal. So the kids hate it when I say this for some reason. I don't know why. But it's such a helpful tool. So horizontal lines are horizontal. They start with y equals, and exertical lines are x equals. So asymptotes in math are a graph, part of a graph that the actual picture part never touches. So there's different asymptotes and that kind of thing in math, but for the most part, you're not allowed to cross your asymptote, okay? There are some graphs that do. We're not going to give you those because like I told you guys, we're keeping it basic in this lesson. So you're not allowed to touch this line right here, and you're also not allowed to divide by 0 in math. So we've been asking you guys to find the excluded values of functions, which we've also been asking you with that same question, how to find the vertical asymptote. So when it says, given the rational function, identify the vertical asymptote, all you're going to do is take the denominator and set it equal to 0, solve that equation, and this one right here is x equals 2. So for this particular rational function, it would have a vertical asymptote at x equals 2, right? Because you're not allowed to equal 2. So there is our natural way of saying, hey, you can't touch this. You can't touch the asymptote. It's an MC Hammer song too. I won't sing it, don't worry. Okay, so then we're going to move on to the next one. Same thing, set it equal to 0. I know we've been in the factor chapter, so some of you are thinking hockey stick. This will work too, but I think it's just easier when you're finding excluded values or finding vertical asymptotes to set it equal to 0. So 2x equals 8, divide by 2 divided by 2, x equals 4. So this particular graph, 1, 2, 3, 4, has a vertical asymptote at x equals 4. You haven't learned how to do the horizontal yet, but that's okay. We'll get there in a second. This one, we have x squared minus 16, which is a difference of squares, so you're more than welcome to factor it. Or you can also just add 16 to the other side and square root. I'm going to factor it just because I really like you guys to know that pattern. Whoopsie. I'll get my white out. X minus 4. Alright, so then x plus 4 equals 0. X minus 4 equals 0. So I get x equals negative 4 and positive 4. You're like, what the heck, Wolken? Yes, this graph actually has two vertical asymptotes, one here and one here. Crazy, right? Okay, what about this one? This one's going to factor in, I'm t-charting this in my head. So if you cannot t-chart this in your head, then you don't do it in your head, you do it on paper. We set this equal to 0. And then we see we get x equals negative 1 and 3. So this one has vertical asymptotes here and here. That's pretty easy to find an asymptote, right? We still have to do the horizontal, and we have to figure out where the points go in these graphs. So that leads us to the next thing. The two easiest types of points to find in math are the intercepts. So we have the x-intercept and the y-intercept. So if you're solving for the x-intercept means y equals 0. So you take the function, which is y, and set it equal to 0. Now, in the last lesson, we learned how to solve rational equations. You need to multiply by the LCD, which just so happens to be x minus 2. So these cancel. And what's x minus 2 times 0? Oh, anything times 0 is 0. So I get x plus 6. Then I subtract 6 from both sides, and I get x equals negative 6. So the x-intercept for this graph is negative 6, 0. So there's our x-intercept. And then to find our y-intercept, instead of letting y equal 0, we find our x equals 0. So this is also something that's a little bit of a mystery to kids, because they're like, if I'm finding my x-intercept, why am I saying y equals 0? So when you find an x-intercept, you're trying to figure out where on your graph it crosses that x-axis. The x's are changing on the x-axis. The y's are all staying at 0. So the y's are the one thing that's consistent, so that's why we can plug in y equals 0. Well, what if I'm solving for my y-intercept? That means here. So my y values are all changing, but what's staying consistent is I don't move at all horizontally, so x equals 0. So when I do this, instead of setting it equal to 0, I plug in 0 for x, and I get 0 plus 6, which is 6, divided by negative 2, which equals negative 3. So this one has a y-intercept of 0, negative 3. X-intercept, y-intercept. Okay, let's move on to B, do the same thing. So we have, if we're finding our x-intercept, we let y equal 0. Okay, so we're going to multiply both sides by x minus 10. And then those two cancel out, and 0 times x minus 10 is 0. So at this point, some students make the very good connection that if you want to know your x-intercept, just set your numerator equal to 0. Why? Look at this. X plus 6 equals 0. 3x plus 5 equals 0. Why does that work out? Well, if every single time you're setting your fraction equal to 0 and then multiplying by the LCD always gets multiplied by 0 and it's 0, and on this side they always cancel out. So some people take it a step further and say, hey, I see that pattern, I understand the math, so I'm okay to use the pattern now. So then we get subtract 5, and divide by 3. So x equals negative 5 over 3. Okay? So we have negative 5 over 3, comma 0. And then for my y-intercept, which is f of 0, I'm going to plug in 0. So one of them you set the y equal to 0, and the other you set the x equal to 0. 3 times 0 is 0, plus 5 is 5. 0 minus 10 is negative 10. So that's going to equal negative 1/2 when you reduce that. So that's 0, negative 1/2. Okay? Now we're going on to this guy. I'm going to speed it up just a little bit. There's a certain student who says they like to make sure, if I could please make sure that my videos stay under 25 minutes. So here's looking at you, kid. You know who you are. I think you do anyways. So I'm just going to set the numerator equal to 0 because I see the pattern. So I get x equals 12. So my x-intercept is 12, 0 for this guy. If you're not sure on that one, just see me at the beginning of the class. Make sure you highlight or star it so you don't forget. And I'll go over how to do that the other way. This one, there is no shortcut. You have to plug in 0. So I get 0 minus 12 is negative 12. 0 minus 6 is negative 6, which equals 2. So this one is 0, comma 2, because it's the y-intercept. So the x value is always 0. Okay, so now we're going to go on to graphing the rational functions. So we're going to use the asymptote that we already talked about. That's the vertical one. And we're going to use these points that we're also learning about. And then we have one more type of asymptote that we need in order to graph these. So here's the steps. A lot of you guys are like, oh, I wish there were steps so I know what to do. Well, look at that. Your voice was heard. Find the vertical asymptotes. We just learned how to do that. That's the excluded values. Find the horizontal asymptotes. That's this chart below, which I'm going to go over in a second. Identify the x and y intercepts. Hey, looky, we already know how to do that. And then the last thing, which we already know how to do, is plot points. So the only thing we have left to do is learn how to find this asymptote. And you have 3 choices, okay? The first choice is y equals 0. Y equals 0 is the x-axis, okay? That's the first choice, y equals 0. The second choice is y equals a over b. We'll go over that in a second. This is just going to be some number, so also horizontal. And the third choice is none. So really it's just, is it y equals 0 or y equals some number? So how do you know what it's going to be? So we need to look at the actual problem we're given. So I'm going to go over this with this example right here. So what I want you to do first is step 1, find the vertical asymptote. So vertical asymptote, I'm going to put it down here. Okay, so we know x plus 3 equals 0, subtract 3, x equals negative 3. Now, some of you might say like, oh, that's more for us to remember. But remember, we already know we can't divide by 0 in math. How do we show that on a graph? We show that with an asymptote. There's one other way, but we're not there yet, so why even talk about it? So we're literally going to go to negative 3 and draw our vertical asymptote right there. Okay? So that's the first part. The next part is the horizontal asymptote. So this is what the horizontal asymptote says. First you need to look at P and Q, and you're like, what the heck? P is less than Q, P equals Q. Well, right here we define everything. So P is the degree of the numerator, the power of x. And Q is the degree of the denominator, also a power of x. Alright? So what I want you guys to do is for the horizontal asymptote, just one sec, I'll move it up. I want you guys to do this. P, Q, and you're going to put a circle in between them, okay? P is the power of the numerator. The numerator is a power of 1, so I'm going to put a 1 here. Q is the power of the denominator. It's a power of 1, so I'm going to put a 1 here. Now I have to fill in this sign the good old-fashioned way. Is it less than, greater than, or equal to? 1 equals 1. So that's where I'm at. So I'm going to go up to this chart, and if P equals Q, this says that my horizontal is going to be the line y equals a over b. Wilkins said it's going to be some number, but how do I know a over b in number? Look right here. A is the leading coefficient of the numerator. This is a 1. So y equals a over b, which equals, a is equal to the leading coefficient. Our leading coefficient is 1. B is the leading coefficient, which is also equal to 1. What's 1 divided by 1? 1. So our horizontal or horizontal asymptote is right here at 1. Okay? So those are the two major parts of any rational function, is the vertical and horizontal asymptote. The rest is just points. So what we need to know is, if I look at where this vertical asymptote is the graph going to hang out up here, or is the graph going to hang out down here? Because it can't hang out in both places most of the time. There are rational functions that do that, but for the scope of this class, they don't. We're keeping it simple, okay? And then I need to know to the right of this asymptote, is it above or below? So the way we do that is we pick points. So the easiest points, like I already said, were the intercepts. So we have our x-intercept, which means y equals 0. So we're going to do that. 0 equals x minus 3 over x plus 3. Then I have to multiply both sides by the LCD. Or, if you've already picked up the pattern, that whenever... What the heck did I just do? We're good. Never mind. I don't know what I'm talking about. It's too late. Alright, so I get 0 equals x minus 3. What I was going to say, though, is that if you've already picked up the pattern, and you just set the numerator equal to 0, I'm okay with that. So I get x equals 3. So my x-intercept is not x equals 3. It's the point 30. So I'm going to plot that point. That point is right here. Yes. If I have a point on my graph below, then this is automatically, this entire graph is below. So it's going to go like that. Okay? Now I'm going to find my y-intercept. How do I find my y-intercept? I plug in x equals 0, so that's f of 0 equals 0 minus 3 all over 0 plus 3, which equals negative 3 over 3, which equals negative 1. So this is 0, negative 1. So up here, oops, I didn't draw my graph nice enough. I'm just gonna, this is gonna look terrible, but we'll be flexible. This graph actually does this. But these graphs don't just have one piece. They always have 2 or more pieces. So remember up here I showed you guys this one actually hung out above its horizontal. But what about the other side? So what we're going to do is our asymptote is right here at what? Our asymptote is at x equals negative 3. We already know our graph is hanging out below this asymptote because of this right here. Yeah? Because we had 2 intercepts, so the graph has to go where its intercepts are. But what about over here? So what you're going to do is pick an x value to the left of negative 3. So if this is negative 3, you can pick negative 4, negative 5, negative 6, whatever you want. I normally just pick the one that's closest. So I plug in negative 4. So f of negative 4. Okay, and we're plugging it into that equation that we're given. Minus 3 all over negative 4 plus 3. Negative 4 minus 3 is negative 7, and negative 4 plus 3 is negative 1. And what's negative 7 divided by negative 1? That's positive 7. So I have the point negative 4, 7 on my graph. Okay, let's go plot it. Negative 4, 2, 4, 6, 8, and 7. So my question for you is this point and the graph, therefore, hanging out above its horizontal or below its horizontal? Well, if the point is above, it's going to hang out above. And then it's just kind of going to coast along the asymptote there. Okay? So, it seems like a lot is going on there, but we can condense it down. And I was showing you guys how this all works. So we're going to flip it over. And if you can remember V, H, X, Y, P, then you can graph these. Okay? So V, H, X, Y, P. So V stands for vertical. So watch how fast we can graph these. So we have vertical x minus 4 equals 0, so x equals 4. Great. V, H, X, Y, P, 4. 1, 2, 3, 4, 5, 6, 7. Horizontal, that's that PQ thingy. Alright, so Miss Wolkin said make this little chart, put a circle in between it. P stands for power. The power in the numerator is 1. The power in the denominator is 1. Those are equal. So therefore, this is the symbol for therefore in math. It's 3 dots in a triangle. So instead of having to write the word therefore, you can just do that. We get y equals a over b. So that's the coefficients that went with those powers. So again, we're keeping it really simple for you guys. That's 1 over 1. So that's y equals 1. So we're going to go here and do y equals 1. All right. So now we need to figure out if the graph is hanging out above or below and above or below, right? So here's something else I just want to try. This is x equals 4. And we're going to do our x and y intercepts real quick before we do that right there. So x-intercept, you set the numerator equal to 0. So we get x equals negative 5. So that will be negative 5 comma 0. So it's right here. So that already tells me that it likes to hang out below. And then the y-intercept, we do f of 0, which is going to be 0 plus 5 all over 0 minus 4, which is equal to 5 over negative 4, which is going to give me negative 5/4 or negative 1 and 1/4. So this will be negative 1 and 1/4 comma 0 up there. So that point is negative 1 and a little bit. Oh, sweet. So I know what this graph is doing. To the left, this one is below this time. So to the left of x equals negative 4, it's below. What about to the right? How do I figure out what it's doing? I'm going to pick an x value to the right of 4. So I'm going to pick an x value of 5 and plug it into my equation. So I get 5 plus 5 all over 5 minus 4, which equals 10 over 1, which equals 10. So when I go to 5, there's a point all the way up there at 10, and it likes to coast along those asymptotes. So I've done vertical, horizontal, x, y, and pick points. V, H, X, Y, P. All right, last one, okay? So we are graphing this one right here. So V, H, X, Y, P. So vertical, 2x minus 3 equals 0. So we get 2x equals 3. Ooh, x equals 3 halves, or 1.5 if you will. So x equals 1.5. That's right here. Okay? Horizontal asymptote. We have to do P and Q. Alright, no problem. P, circle, Q. P is 1 and Q is 1. So it's the power. P is 1, Q is 1. So those are equal. So when I do my horizontal asymptote, it's the ratio, it's that fraction that's in front. So it's 1/2. That's alright. We're not afraid of fractions. Okay? Now we're gonna do our x-intercept. I really should edit that out, but I'm not gonna. Too much work. So we have 0 equals x plus 6. So we get x equals -6. So this is -6 comma 0. So here, and then my y-intercept is going to be f of 0. So I get 0 plus 6 over 2 times 0 minus 3, which equals 6 over -3, which equals -2. Yes, I'm going fast, but the cool thing is you can pause the video. Yay! Alright, there's 0, -2. I don't think I'm making my cutoff at 25 minutes, but I'm close. Alright, so there's that one. So I've done V, H, X, Y. I just need to pick a point on this side to see what the graph is doing. The number right here is 1.5, and the number just to the right of that is 2. If you decide you like 3 instead, you can use 3. It doesn't matter. So, you know what? I'm going to show you it doesn't matter. Let's use 3. So my point I am picking is, for my point, I'll write it like this time. I'm going to do f of 3 because that's over here. And I want to know what the graph is doing over here. So 3 plus 6 all over 2 times 3 minus 3, which equals 9 over 6 minus 3, which equals 9 over 3, which equals 3. Oh look, a nice neat number. So this is the point 3, 3. 3, 3. It's above. And that's it. How cool is it that you're at a point in your math education where you're graphing graphs like that? I think it's really cool. I know it's not your favorite thing, but still kind of awesome. You have to admit. Alrighty, have a good night.